Hello everyone. So yes, my name is Nicolas Auger, working for Michelin, working in the Industry 4.0 team as a product owner. And it's a pleasure for me with my two folks here, they will introduce themselves later, to talk about planet with you, to talk about environmental footprint, to talk about data, of course. But then we are going to talk about how our industry can impact the planet, how we can impact our industry to reduce the planet impact. A bit tricky. So let us bring you to our journey, a journey to sustainability. You know that in Michelin we have a great ambition about environment, about the 3P, people, performance, and planet, planet, planet. This is important for us. And this product is clearly on this way to work on our planet impact. We want to reduce the energy consumption in our factories, all our factories, all around the world. And for that, we are facing a lot of challenges. Of course, first challenge is to have the data, standard data, which is a dream of everyone in this room, I'm sure. Standard data about sources coming from everywhere in the world. To process a huge amount of data, okay, we are not talking about 1 or 2 sensors, we are talking about thousands and thousands of meters. And also, to make energy consumption accessible for everyone in the industry. Energy is not a problem of just some expert. Energy is a problem of each employee working in industry in Michelin. And this is what we are going to share with you. For that, you use several technical solutions that my colleagues will share with you much better than me. We use Aveva Pi server, of course, and some cloud computing, some BI tools like Power BI, and also a mobile app to make sure that everyone has energy consumption in his pocket. What are we doing? Energy product. Why are we doing it? So I just share a little bit with you, people. Performance, profit, and planet. We are creating value for those 3 axes. For Michelin, everything has to be sustainable. As we said in a good French, tout durable. If we start with the people, of course, this kind of product will be more attractive for people. It will help people to measure, to get the data, to have a dashboard, to have everything in only one place. It will simplify the analysis of the people, of the experts, and it will help also them to react proactively with automatic alerting. About the performance and the profit, you know the situation for international context. And of course, behind that, we have a lot of saving. Our aim is to reduce globally in all our factory, in average value, 3% of our energy consumption. Last but not least, you understood me, the planet. Behind that, we have a big impact on the planet. We want to reduce the impact to the planet. And this product, by monitoring and alerting, have the objective and the ambition to reduce per year about 120 kilotons of carbon dioxide. And this product includes several personas, a lot of users, I told you, everyone in the industry. So all the people in the industry, they don't have the same need. Okay? We will not discuss with a frontline worker as we discuss with the energy expert in Central. Okay? So we are describing and we are doing some tool really adapted to the usage. The first tool is mainly from the frontline worker steering his process. It's a way to monitor, to steer, to react in, let's say, a few minutes. This tool will come back on it later, but we did it. We have it already on the shop floor. It's Pi and Pi Vision. Okay, the guys through Pi and Pi Vision can monitor, can react quickly on his process. This is the first persona and the first tool. The second tool we are working on is a way to understand more complex situation, complex phenomenon, to really understand what happened for energy consumption, to compare, to benchmark between the factories, to define the good practice, to spread the good practice all over the world, and then to correct and to optimize. It's a tool based on the BI. We'll come on that too. And the last one, I told you that everyone has to be an actor of energy sobriety in Michelin. So we are developing an app, okay, with data, gather data, simple and very UX thinking app to help people to know what is the energy consumption and the situation of energy is in own entity. Another point I would like to share is not a new approach for Michelin, but a little bit change of mindset for the industrial people in Michelin, is we are dealing with a product approach. We used to do a cahier des charges, specification for a machine, we give that to engineers, and then they deliver a machine. For product, as you know, for digital, it's very complicated to do that, and things are changing a lot, and we adapt to our users, and we have to be very reactive. We want to deliver quickly. So we use a product approach. We try to deliver new functionalities, what we call new version, each quarter. We started with a basic foundation to say that, okay, all the data, all the counter has to be connected in a standard way, and so on, which seems so simple to say, but so complicated to do. And then after, I will share with you that we are tackling each big consumer. That means in our manufacturing, we have process families, and we check what is the process, what are the processes, who are the big consumers for that. And step by step, version by version, we are working on those big consumers to reduce energy consumption. At the end, we'll have some transverse topics, like managing the fluids, which is not easy as well. Nothing is easy in this topic. To detect a leakage, to manage the distribution, and so on, and also to manage the infrastructure, the utilities, and to optimize all of that. We did this product based on the need, based on the value saving. This is why you have this chart, the process families curing. It may be something surprise for some one of you, but we cure the tires. Mixing to prepare the compound, and all the process families like this. I will not forget our colleagues from synthetic rubber, ESBN, is a place that we are producing the rubber as well. So you see that there is version 4, version 2, version 7. All the version of our product creates value. If they have a version which doesn't create a value, it's not really a version. We are focused on value creation. Before to give the floor to my colleagues, just a key word about what I said. The key driver for that is, first, each employee knows what is the energy consumption in his entity. Each employee is on board and is an actor of energy sobriety. And we would like, and we want, and we will make sure that energy consumption, energy is a KPI of our manufacturing. We optimize so far our production for quality, for productivity, and then we want to add energy. Okay? It really has to become a KPI for our manufacturing. The key features, you may know it, but we start by monitoring, alerting, prediction, prescription, and optimization. This is the way we are moving to that. It seems now so easy to do, so easy to say, but we are still facing two big challenges that my colleagues will share later. First, fast scale-up. We don't want to do that just for the headquarters in Michelin in Clermont-Ferrand. No. We want to do that everywhere, quickly, because you know the international context. We don't have time for that. You know the situation for the planet. We don't have time to wait. So we want really to make a fast scale-up. So it has to be designed for the scale-up. And then also, what is new for this kind of product is we want to be able to cross the data between all the factories. The factories are doing excellent things. The factories did a lot of local initiatives which are excellent. What we want is to cross the data to spread out all the good practices. Then I will give the floor to Fred because I speak too much. And it's your turn.
Good morning, Frederic Eyraud. I'm a freelance PI expert and I work for Michelin since the beginning of this project for them. Let's get to the new slide. You know, in Michelin we use Aveva PI system for 5 years. We have bring our 70 factory with PI system, and a lot of work has been done. But when someone comes to you and asks you to say, okay, we need some energy data inside the cloud, the expectation is, okay, we take the data from one counter and we bring it to the cloud. In fact, in the reality, when you look what we already have on site, there is thousands of counters, there is different type of counter, there is different type of attributes, everyone got his own units. So believe me, it's when we multiply by 100,000 counter over 70 factory, it's become a real nightmare. So how we can do that? To do that, we need to standardize data. That's the basic. So to standardize data, actually, if you have seen the presentation from Michelin yesterday, we used the bottom-up relation with our site. So they have developed already some information using the PI system. So basically, the information of their counter already arrive in our asset framework and inside some local PI Vision screen where they use it for the monitor and react application. So one of the possibility that we have with asset framework is we can link template together. So basically we can develop some corporate use case template, link them to the local template, and like that have some standardized information that we can export to the cloud. This is the solution, because we don't want to change what is done on site and what is working already. So now how we scale this solution, because we have thousands and thousands of counters to do and over a lot of sites. So to scale that, in fact, we develop a tool. Because we have the method, our method and tooling, we need to develop a tool. The tool we develop inside Michelin called the Mapib. It allows the local user to list all their counters, then associate each of the counter to a local template. And it's the same tool can be used by the corporate, by the central team to develop the corporate use case template, and then link the corporate use case template to the local template. Once that is done, each site can, as a bulk, deploy all the counter inside the tree, inside the knife hierarchy, and we will find all the information, the local information, the standard information, and all that can fly to the cloud. At that stage, we have a lot of data coming in our database, so a lot of information coming to our database. But data without context is not data that we can use. So we need to add context to this data. The first context we have added, it's the relationship between the counter. So basically, it's your distribution or your electrical schematics or your PID if you speak with vapor or the fluids. So for that, we have developed a method that each site can describe into the PI asset framework hierarchy using our tool. They can describe the exact schematic and the exact distribution of each counter. Having added this context, we had a layer of intelligence on. We had a layer of intelligence at the early beginning. So basically, we can do model consistency. It's complicated for a French guy, this word. Model consistency check. So before we validate, okay, if these two counters are not exactly the same, then maybe there's an error and we need to relook at the model. Once the model is validated, then we can do leak detection. Okay, these two counters, there's a single line. If they are not almost the same, there's a leak somewhere. We can do model detection. So basically, our model can be dynamic. If I close this switch, then the model is not active. It's not the same model that I will use to calculate the consumption over C9 and C10. We can help the decision for counter installation. Here I have a branch when there's no counter. It's happening. We cannot put counter everywhere. If this branch is 0.2% of the global consumption, I don't care. Let it like that and use a virtual counter. If this branch represents 20% of the consumption, it might be useful to invest into a new counter to have more detailed data into our model. The next context that we want to add, it is the localization context, the position of the counter. So I explained to you that into Michelin, we have made a lot of job. You can see our presentation 2 years ago at the Amsterdam PI World done by Pascal over there. And explaining to you that we have developed all our asset model onto the 70 site. So we have already all the production assets modelized into Pi with the information for like the sensor, context information, product identification. Now we give the site the ability to have an energy tree, what we call the energy tree. So basically the model of the energy. And with the possibility that we have into Pi Asset Framework, we can make a link between the energy tree and the asset. So we can say, okay, this counter is at this position on the asset. And like that, we can start to cross-reference, make cross-reference between energy information and production information. So when we have the production information associated to some counter, then with a very, very few information, like the batch ID, batch weight, running status, energy, and the energy data, we can easily find that crossing information gives us the quantity of energy that I use to make one batch. And that we can declare, use this information into many places inside the factory. As industrial operation, I can make the comparison between model and between machine. Why is the same batch or the same recipe on machine A in Thailand is using 20% more power than the same recipe on machine B in Germany? That happened. Huh? You can make optimization related to the energy. For the maintenance, we can make target batch, and then we can make drift detection. So if the change, if the machines start to change on the same batch, maybe there's something to see. We can make prediction for energy consumption to buy the energy on the open market. And in production management, we can make some planning over the energy KPI. To do that, you need another level of computing. So that's Baptiste will explain to you, because this part is inside the cloud.
Thank you, Fred. Thanks a lot. So hello, everyone. Thanks for coming so numerous. Thank you. So I'm Baptiste. I'm the technical leader on the solution. And now I will take the cloud and compute part. It's not working at all. Ah, not a good one. OK. In the cloud, we think that there is 3 steps on the journey of the data. First, data gathering, then data processing, and finally, the delivery. Each part has its own main problem. For example, on data gathering, we have 70 factories. It's a lot, and no standard. So, as Fred explained to you, we managed to put a standard on Pi, thanks to Pi, to have standardized data over all our factories. On processing now, we have to process a lot of data in less than 2 hours. In fact, we are processing batch of data every 2 hours. So if we get more than 2 hours, then we have to get some late and some late and some late, etc. To do that, we are using Databricks. So you may know them. They have a stand here. To have distributed compute using a cluster, a lot of workers, parallel workings, etc., etc. Finally, the delivery. On the delivery side, we wanted to have less than 20 seconds between the request of the user in Power BI and the answer, the display of the values. To do that, we use also Databricks and a component called the SQL Warehouse that allows us to have really fast answer. For example, if you want to have 15 machines consumption hour by hour over 4 months, it takes only 8 seconds to have the answer. Also, if you want to have a big benchmark at the operation level between 8 machines, you can do it in less than 20 seconds. And all of this part has been provided by our cloud expert, Thomas. Now, about processing, we are processing every site in parallel. So site 1, site 2, site 3 are sending standard data into the cloud based on the templates that Frederic spoke about. We are doing data quality because having a lot of data is cool, but having a data of quality is better. Try to follow. There's a lot of Michelin guys here. You should know that, you know? Well, so we have data quality process on raw energy data coming, and then we have 2 layers of aggregation. We have aggregation on time, so energy consumption every 10 minutes. And then we have also energy by events, by status of machine, by context, by cycle of the machine, etc., etc. This allows us to have two generic data sets for all possible machine and all possible process with data quality to have a generic usage of hour by hour consumption and consumption by machine status for all Michelin machine. Then, when we develop specific versions, as Nicolas said, on mixing, on curing, etc., we just have to link this generic data to production data coming from other systems based on this process. And then we have the specific version. And this is managed by Olivier, our data engineer. I talk about data quality. We used machine learning to do that. So we use isolation forest, the state of the art, let's say, of the anomaly detection. So it detects inconsistent values within the population, just as you can see. Then, when we have a value detected as non-consistent, we just give a score to it. 0 is good and 1 is bad. You can see here the red dots have a score of 1. We score the values depending to its gap between the normal signal, let's say. The problem is, with this kind of model, we have to train it. And every signal, every voltage, current, power of every counter is different. So we have to train for each attribute. So we have to train for, at the moment, more than 30,000 models every 2 hours. It's a lot of models training. And so we are doing parallelization of the trainings that allow us to have it in a short time. Finally, you can see that when you have some strange values like here, and when you filter on data quality, it will just disappear and you will have a way clear signal to usage, to analysis. So this is a lot of data, this is a lot of process, etc., etc. How does it be used? What are the KPIs on it? So you can see that from the beginning to right now, we have processed more and more data. At the moment, we have reached the 4 billion data each month. So a lot of data. Over 15 factories at the moment. Also, our usage get bigger and bigger. We have started at 300 usage in February. Now we are at 3,000 of the product, of the data we have here. And then we try to manage to keep the cost as low as possible. So it's what you can see just below. It's the cost by factory. So by factory, we have managed to keep a really low cost, but cool, not low cost as bad, you know, a really low cost solution. At the moment, it's less than 350 euros per factory per month. So we managed to keep it cheap, let's say. Not expensive, at least. Some success, because, well, a lot of data, not so expensive, but do we make money with it? And do we save the planet? Of course, it's important. So, some success in mixing. As Bruno told you yesterday, Bruno Baptiste, we have two approaches, central and local, from the factory and from the central. From the factory is what we call local progress. We have some progress up to 10%. For example, in Web Factory, they manage by just adjusting one process parameter to gain up 10% of energy without any impact on quality and productivity. Also, on other optimization locally, we have gains up to 3 or to 5%. In Central, also, this tool allows for the first time to compare factories, compare different machines. And this, thanks to this, we managed to find that on some type of product, we can earn up to 16% of savings just by changing the process parameters for the same product at the end. Also, just by comparing two machines, we find that we can have 10% of gains by doing a production on one machine and not another. So, thanks to this, we can have a lot of gains. In curing now, what we have done, we had another problem in curing. In curing, we have no counter, and it's steam a lot. So we have to find a way to do it without buy thousands and thousands of counters. To do that, we try to calculate in pi, with an analysis, the steam consumption, and we managed to do it. So now, at the valve level, we have the steam consumption hour by hour, and then even in real time. This allows us to have the steam consumption by machine and for 0 capex, not by any counter. And overall, if we check the model consistency, we have less than 10% of difference between a physical counter and our model. So we are quite proud of it. Also, now that we have the data machine by machine, it allows us to be able to compare the machine on same type of production to see if you have one that is consuming more than another. And we expect to have quite the same gains that we have in mixing. And to finish, I will let the hand to my wonderful product owner, Nicolas. Thank you.
What can I say more with these words? Thank you, guys. So, standard data, cloud. We can compare the factory where a huge amount of information. But if you remember well my introduction, what we want is people to be on board. Everyone has to be an actor of energy sobriety in Michelin. So to give a nice Power BI, excellent for experts, but no, all our people in our industry will enjoy to go to Power BI to analyze the curves of energy consumption. This is why we are developing, so by Com and Yara, we are developing an app, okay, so based on design thinking, based on a user approach, of course, like maybe someone have in his pocket about the energy consumption in his home. Okay, we try to focus a little bit about this kind of app, but based on industrial data. And also to make sure that everybody goes on board, we use some gamification, some scoring to make it fun, to enjoy people to join us on this journey. Like, I don't know, you may know this kind of app, like a Duolingo, for those who want to learn foreign languages or something like that. You will earn some badges, some diploma, and so on. So we are working on that to make sure that everyone is aware about energy consumption. To be aware about energy consumption is the first step of the reduction. And this happens every day for everyone of you into this room, that when you check the energy consumption in your home, this is the first step for the reduction. Okay. So this is what we want to do. Remember this slide, sorry, at the beginning. Standardized data, huge amount of data. Make sure that everyone is on board and access to the data. Use Pi server, use the cloud computing, mobile app. We are on this way, we are doing it. So far, we did it for more than 8,000 meters in the world. On the slide, which is made a few days ago, it was 15 sites, but I'm happy to share with you that now it's 20 sites. During the last 2 weeks, we added 5 sites more. So this product is designed for scale-up. It's not easy every day, but it's designed for scale-up. And we can, as Baptiste said, we can do some benchmark between machines. People really enjoy to use this product and ask more and more and more of features. So this is cool, this is nice. This is really what we want, that everyone is a part of this journey. Thank you very much for your attention, and we're here for your questions.